morning. Everyone can hear me? Welcome and thank you for coming to B-Sides Las Vegas, ground floor. This talk is called Hardening Containers with SecComp, and it's being given by Ben Hirschberg. I have a few announcements before we begin. We'd like to thank our sponsors, especially our diamond sponsors, Adobe, Aikido, and our gold sponsors, Profit and Run Zone. It's their support along with other sponsors, donors, and volunteers that make this event possible. These talks are being streamed live and as a courtesy to our speakers and audience, we ask that you check to make sure your cell phones are set to silent. If you have a question, please use the audience mic so that YouTube can hear you. Make sure to point at the mic. Sorry, I'm reading what it told me to do. You may be asked to make announcements. Oops, sorry. As a reminder, B-Sides Las Vegas photo policy prohibits taking pictures without the explicit permission of everyone in the frame. These talks are all being recorded and will be available on YouTube in the future. Thank you so much, and without further ado.
Good morning. Sorry. Good morning, everyone. Thank you for coming to this talk. I will try to be easy on you this morning. You know, it's early morning for first talk. I see that most of you still have your coffees on, which is great. Hope that this will work smoothly. I'm going to give you 2 live demos. Let's hope that the demos will work. If not, then we'll switch back to recordings. So those of you who don't know me, my name is Ben. I'm a co-founder and CTO at a cloud security company called Armo. Used to be worked at different places before. I'm working in the security industry for more time than I want to admit, but coming from a white hat background and going into more to product and development part of the industry. We are going to talk today about an open source project I'm a maintainer at. It's called Kubescape. It's part of the Cloud Native Computing Foundation, which I'm an active member of. Yeah. Let's go in. So, among you, first of all, who heard before this talk about SecComp? Who's using actively SecComp in their products? Okay, great. So actually, this is really the talk is about. So the talk is about what is SecComp and why it is not really widely adopted and used, and how this can be, how we can turn SecComp into something that is more usable at least in the container and cloud security sphere. So I'm going to talk today about what is SecComp, giving an intro for those who are not, who don't know what it is, and then we'll go over how it can be used for prevention in containerized environments, and then I'm going to show you a way to be able to make it much more usable using application observability and understanding how applications are behaving, and then applying the right profiles for the given application. And I'm going to do a demo. I've come with a real exploit in a real application to showcase you how it works. So, SecComp is actually a rather, I would say, old feature in Linux kernel. It's, I think, I haven't checked it precisely, but it's been around something for nearly 20 years in the Linux kernel, if I'm not wrong. But even if it's less than, not far less, it was born in order to be able to build sandboxes, process sandboxes that are running on Linux kernel, and is it was built for two purposes originally. One was to build sandboxes around things like browsers that are running less trustable code and were prone to different exploitations before, and therefore there was a need to create a sandbox around these applications to limit them. So even if there is a real exploit on them, then the attacker won't be able to proceed to the next step. The second reason later become is to limit also system calls that may be problematic for the kernel, in the sense that if there is a system call that has a known exploit in a given version, still the defense can use seccomp to limit calls to system calls if the application doesn't need them. So the original history was that, again, 20 years ago, to create processes that are limited only to 4 system calls. The way it worked is that a process that when it started up could call into different system calls and just limit itself from any further system calls, like going down in the privilege scale. These 4 system calls were read, write, and exit, and close. So in general, the idea was that I can create a sandbox process, which is just like, doing some basic I/O, maybe closing some file descriptors, and then it exits. Again, think about the use case of browsers and executing JavaScript in the browsers. Then after it come a more complex version that was using BPF, which later become eBPF, to define much more fine-grained rules around what is allowed and what is not allowed for the process to do, and creating very complex scenarios, even just not simple firewalling scenarios, but checking into the arguments and so on. So seccomp became much more powerful in the early 2010s. And then when the containerized environments started to come up, Docker came up. The guys at Docker came up with a great idea to create a basic profile, which we are going to talk about today, that limits the system calls of a containerized process that it can do, and generally protect not just the application, but in general the host machine that runs the container from attacks. And as containerization evolved, Kubernetes itself, which is the de facto orchestration tool today for containerized environment, also started to support 5 years ago fine-grained seccomp profiles. So what's the present state? So the present state in general is that there are pinpoint usages of seccomp, again, browsers, very specific applications where seccomp is used. I've seen very interesting usages as well for seccomp also into intercept system calls, and I've seen great interesting things, but in general, the security industry, or parts of the security industry, know seccomp for Linux hardening, and it's great. But in general, in the main, in the most places where our Linux today is used, and Linux is used for very broadly, obviously, in the cloud, it is much less used. It is very, very rarely I see companies are taking advantage of seccomp to protect their environments. And this is the thing we are trying to change and to make seccomp more usable. So why it is interesting? Why seccomp is interesting in cloud environments? So seccomp is interesting in cloud environments because the main threat model of cloud environments, and especially if we are talking about containerized environments, is twofold. If we're assuming that there can be some malicious code that is running inside a container, the attacker can do two things, or advance to two directions. One is to try to create an exploit on the kernel and somehow, leave the confinement of the containers and take over the VM or the Linux host that is running the container. This is one thing. And usually when this is done through some kind of system call that the attacker is able to invoke with specific parameters, and then it enables it to do a container escape because exploiting some kind of a vulnerability that there is in a kernel that wasn't patched, or maybe it's a 0-day and no one knows that there is an issue there. That's one thing. The second thing is that the attacker might try to do some lateral movements, maybe not trying to attack the kernel itself, but still the workloads are rather unlimited in what they can do in their environment. So they can talk over the network, they can invoke different network calls in their environment if there is like no network policies around that are super limiting. Files that are written on the disk and so on, maybe environment variables, so on. So there are like plenty of things to do, lateral movements too. And these two, in this threat model, attacker can either come from exploiting exploiting vulnerability inside the container and coming from the outside world, and it comes from the public internet, or it's just like adding itself into the supply chain and the containerized environment starting a container that already includes the malicious code. And this is our basic threat model. So the way I see it is that one of the ways that seccomp would be really great for containers is to limit the availability of an attacker to what it can do to the progress attack. Maybe not limiting the actual exploit of the initial attack vector, but to create these lateral movements or trying to go over to the kernel to continue an actual attack. And I think that this is where seccomp can be super useful. So let's talk a little bit about how seccomp works. So seccomp for containerized environments is working in a very schematic way. As I told you before, in general, seccomp, if you are programming it through the Linux API, you can create very specific use cases and implementations of limitations. But if you are higher level abstraction layer like a container runtime, you don't want to allow all the users to all these features because it's just super complex to do, and it would require deep knowledge of programming. So the way that Docker originally defined seccomp profiles, and this is a very big difference to know that in between the seccomp API of Linux kernel and the seccomp profile of the container runtime. So the seccomp profile of container runtime is defining this very schematic way of there is a system call, it has very specific arguments, and just tell me what should I do if this happens. So if there is I don't know a fork system call, then block it. Don't let the application call into fork or clone and prevent it to create new processes. Or if there is close system call on file descriptor 5, then just block this system call. And this is how the schematic seccomp profiles for containers are looking like. They have this list of of system calls, but optionally arguments, and what to do with them. And this is how they look. So what are the actions? SecComp today enable you to do different responses in case of different system calls and arguments. So the most basic is just to say allow, let it go through, don't care. If you are going from lowest priority to upper, which is like from the bottom to the top, you can ask SecComp to log this event, and then it will be written into the kernel logs. I will tell you in a minute why it is super unuseful in a cloud environment, but we'll come back to that. There is this notify option when you can hook into, create a hook into Linux kernel and get notifications about a system call event. You can configure the Linux kernel that if there is such a system call, then just return an error code like not allowed, and you know the application continues to run, and it will just get an error on this system call, and that's it. There is this trap signal. You can also define SecComp to throw a signal on the process. It is for applications that are very aware of how the SecComp API works in the Linux kernel. I've used it a few times, but it's just like for very niche purposes. And then obviously then you can have the kernel to kill either the caller thread or the whole thread group, the process in this case. So kill the application in general if there is the invocation of the specific system call. So you have all these options. Now I wanted to return to the logging option. So you're thinking that it's like super nice to like define that if there is an application that is like calling to a very specific system call, and I just have a log event about that. Now the problem is that most cloud environments, it is like really hard to create this feedback loop because these logs are not really collected anywhere. There's no standard way to collect it. There's like a very specific implementation for each cloud environment, cloud provider. They are not at the upper layers of container runtime, Kubernetes. It's just like these logs are, you have no unified way to access it, and it's like a shame, but this is what it is. So again, returning to the point that I had before of the difference between the system call API and of SecComp and the SecComp profile itself. So the way you're working with SecComp, in case you're using directly the Linux kernel API, is you have like two. Mostly that you have the SecComp system call itself, which is like has a man page of which is like super long. You have to, including BPF instructions and everything. It's hard, complex. Most people need to invest a lot of time to learn it. On the other hand, in the containerized environment, to implement, it's not really a programmatic implementation, but you're just defining this JSON configurations of like what I told you before, that when this system call happens with these arguments, what to do. That's it. The format is, the complexity of these two things are really, really different. But I'm going to return to this because I could really say that it's really hard to learn the SecComp API. It's like any other kernel feature. You have to really learn how it works to be able to control it. And the JSON file is much more simpler. But having said that, like today, it's really hard for people to understand even the JSON file because of other reasons. So so we'll come back to this a little bit later. So how this JSON file looks. Sorry for the small font. I hope that you can still see something here. But again, it is like this super thing list of, you can see syscalls, items. For every item, there is a string for a list of the system calls, and then the action to take. So you have a specific system call, for example, close. You can define the action to take. You can define the argument filtering of I want to apply on this this action only if there is a given argument to it. the argument filtering is like super complex, and because think about the following things. You would say, what kind of argument filtering I would like to implement? Like, obviously, I wouldn't like anyone to open a file called /etc the shadow, because I just want to prevent it. Now, how the kernel sees this string? How the kernel sees this string? As a pointer to username, to user space address, and like seccomp is not good at it. You cannot read directly this, and even maybe with ePPF you could read that, but it's like super complex. Nothing that this JSON file can handle. So it's you know, this argument filtering is just partially useful. So if it's so cool, why is it not used? So the main thing is that, as opposed to, you know, I guess you came to this talk because either you know Linux security, you heard about kernel, you're interested in, and you heard what this system call is. But it's hard for me to break you the news that most people in the world who are in this industry doesn't know really what the system call is. And people just don't understand, the developers don't understand this notion. Like, think about it, and I do really trying to say this without, you know, without any hint of disrespect, but think about the Java developer. If you ask him, okay, what kind of system calls you're using in your application? Like, he's going to be like, well, no idea. So it's really hard to like create an environment where people are aware of what system calls they need in their application. So think about a containerized application. I ask you today that, for example, you are using a super simple application called Elasticsearch in a containerized environment. Like, what system calls it use? Then the next question is, okay, which version of Elasticsearch? Which version of Java runtime? And you start to think that it's becoming super duper complex discussion. And then afterwards, like, okay, I'm as a security person, I'm creating this environment when I'm limiting system calls, and for some reason it looks like the container is running, it's not crashing. Is the application working? Do we know that the actual application is not broken, like, because we are limiting something that that is hidden behind us? So it's really hard to understand as a security practitioner, okay, that we are not breaking functionality. And now I'm returning to this notion of like seccomp has that logging, blocking system calls that are blocked. And the problem is that since we don't have a reliable or unified way to understand that we've blocked something in a containerized environment, it is really hard for us to understand that we broke something. So it's very complex. So now how it's, you know, tapping into the ecosystem of the containerized world. So as I told you before, Docker, when it came out, and all the other container runtimes that came after, just inherited this property that when you are running a container, it already attaches a default basic profile of seccomp. So if you're, and I'm going to show it to you in a demo in a minute. So when you're running a container with Docker, just Docker run or Podman run or whatever, it is there is a seccomp profile active behind the scenes, which is like, I do think that, you know, whatever you think about Docker, from my perspective as a security person, kudos. Like I really love when a vendor comes out or project comes out and they are just like trying to be really strict on security, and it's even like works to some extent. So it's great. On the other hand, came Kubernetes, which is like, you know, I would say my home team. I'm a contributor to Kubernetes and work, and you know, as part of CNCF, it's our project. But I have to tell you that the less good part is that when Kubernetes came out, when you're releasing the first version, you just want to make everything work, right? So what's the first thing you're disabling? SecComp, security, no security. So Kubernetes disabling SecComp in the container runtime by default for every workload you're running. So you're not inheriting the good things that Docker came with. And reintroduced in 1.2, Kubernetes reintroduced the support, so you can define the basic SecComp profile, or you can bring your own. So so you have these three ways to work in Kubernetes. Either you are running in an unconfined environment, which is a no SecComp. You have the default profile, which is the basic profile of Docker, which is, by the way, a little bit changed over the time, but it's not super interesting, so I don't want to go in there. And you have the local host profile, when you are just like bringing your own SecComp profile into Kubernetes, and you're running a container with a custom SecComp profile and praying that it works. So let's talk a minute about the basic built-in profile. So actually, it's really cool because it blocks only around 50 system calls. Again, I don't have the specific number because it changed over time. But it blocks out a lot of system calls that were usually really not used in the containerized application. Think about mount, pivot root, and stuff like that, which is usually in the normal application. It's not like system calls that are used. But they are like really good things for an attacker to use, right? They are like system calls that are also, they were prone to different attacks, and also it's just like something that the attacker would love to have, especially unshared to exit a containerized environment. So they are working really smoothly. There are a few applications that are not good with those, but in general, most applications, like 99% of the simple applications, are working good. Mostly, I could say the same about databases. There are a few exceptions with that, because different file system management related system calls that are like just making problems with few database setups, but in general, it's working. And there are like also very, very specific examples of well-known CVEs in the Linux kernel that are just like not exploitable if you have a by an attacker if you have a the basic SecComp profile in place. Now I'm bringing you this really, really super nice screenshots about custom profiles. These are super cool. Again, no one understands really what's happening here. Like you have just like this list of system calls that are allowed, and that's it. The reason why I wanted to show you this slide, because it's just like I wanted to give you the feeling that it's complex. It's like, to understand what's in here, you have just like a list of system calls, and that's it. And it's hard. So I'm going to show you the simple demo. I just wanted to do a little showcase of how the basic profile in Docker works and what kind of things it prevents. So I'm going to run two nginx containers, one with the basic profile and one is unconfined. I'm going to try to create a child namespace in both of them, and I will try to access the kernel keyring in both, and I'm going to show you that the server is still running. Now, sorry for, let me go over to, okay. Okay, so let's go over it. So we are starting the two containers. So you can see here that the first container, do you see this right? Or should I? Okay, I will try to, let me try to go over. Scholars, let me maybe Where is the white? Is it better? This is experience, guys. So we've started one container. This container is running without confinements. I needed to, since this is not the default setting, you know that I needed to tell Docker to run it unconfined. I'm running the normal container, which just doesn't have this option, and it's running by default. So I'm just installing the key utils, which is like less of, and hoping that the network is working. Wow. Okay. This is the nice part of the live demos, that even you're fucking up with the step that you didn't think that it will go wrong. Let me try to see that the network is going. Let's give it a second and we'll see if it's able to download. Okay, let's switch over. I'm switching over to my phone, restarting. Let's restart. Yeah, eventually we'll come over all these problems. Okay, so what you can see here is that I'm checking that whether there are any seccomp filters applied. None of them in the unconfined container. I'm trying to create a new Linux namespace. I was able to create it. I'm trying to access, the keyring. I'm able to create it. So on the other part, let's see if seccomp profile is enabled. You can see that there are like seccomp filters installed. I'm trying to create a namespace. I'm blocked. I'm trying to access the keyring, unable to do this. Okay, and I'm also showing that actually Nginx is working. So that's the third thing I wanted to show you. So now returning to our discussion. This is, guys, there's going to be more interesting things, guys. So sorry, I even thought of removing this demo. Like I just wanted to show something really short. But in general, so the problem is that with the basic profile, that there are like still a lot of things that can be exploited with the basic profile, and there are not a lot, but there are applications that are not working simply with basic profile. So we are like, it's like one glove that tries to fit all. Like it's not working everywhere. So, so the question is like, if I'm trying to go over and build better tailored seccomp profiles, what can I do? How do I know which system calls are running and which system calls are not? So there are obviously like, tools to understand and list it, ptrace and so on, but these are like very problematic to use in a containerized environment. It's also if I'm trying to create for a very specific application, for example, I told you Elasticsearch, to create a seccomp profile that it's tailored to it. It depends on the actual configuration of the application. So again, I'm getting back to the same problem I was before, that I'm trying to create a generic application profile that will allow system calls that shouldn't be there. And the issue that what if I'm blocking something that I should be blocking according to profile, but in general it's used. So I have a problem. So the whole thing was built up to this point to bring you that, okay, there is a future there is a future here to build upon. And this is one of the things we try to solve in the Kubescape open source project. So just a little word, because we don't have time and I want to go to demo. So in Kubescape is a Kubernetes security platform supporting for postural things, for vulnerability scanning, configuration scanning, to supporting generating network and seccomp profiles that you will see, and runtime detection tools. If you want to get to our website, scan the QR code, and then if not, it's Kubescape.io, so you'll find it. So the way Kubescape is working, Kubescape has this node agent that is running on every Linux node, and it just sees all the containers that are running and sees what system calls they are invoking. So it really learns how the container behaves, and since it's logging the system calls that each container uses, it can like create this list of per container of the system call usage, and we are using eBPF to do that, and what the point is going to be here that when we have these Kubernetes API objects that Kubescape creates that we call application profiles, that are logged per each container the application behavior. So it logs the processes that are running, the network connections, the file access, and all these like good things that a security engineer would need. It also logs the system calls. So what we are going to do is we are going to use these application profiles objects to turn the list of system calls into seccomp profiles automatically. What I'm going to show you is I'm going to showcase you the power of this through a CV which I prepared for this demo. It's in the change detection project. That CV is enabled a server-side template injection attack. So actually, I can through a Jinja template, I can inject Python code into the server side, and I can run anything from the client to the server, and I'm getting arbitrary code execution of the container itself. So what I'm going to show you in the second demo, which again, hope it will work, is I'm going to try to inject code that steals the Kubernetes service account token, which is, if those who don't know, every Kubernetes container by default has this service account token mapped into the container, which enables the container to authenticate itself against the Kubernetes API, which is, think about it as just an API key that is located in the Kubernetes container. It's just like a cool thing to steal, because afterwards you can talk to the Kubernetes API using that. So what I'm going to do, I'm going to show you the exploit itself in an unconfined container. Then we'll generate a profile based on the application behavior, apply that profile, restart the container, and then we'll try to re-exploit it, and if everything works, we are going to block the actual exploitation itself. So let's go over, and fingers crossed. Okay, so it is, the things are up and running here in my Kubernetes cluster. So I have pre-installed this change detection application, which is the vulnerable application, and Kubescape is running here in the background, which I will talk about a little bit later. Now let's do an exploit. So the way it works, I'm going to talk with this service through port forward, which is just like a technicality for me to talk to it. So I'm trying to exploit the actual SSTI vulnerability. I need like I've taken the publicly available POC and turned it into this demo, so it's not, the credit is not coming to me. I did some just small tweaks. So I'm obtaining the token, CRSF token. Let's hope that the webhook site is working, because I wanted to show you what we are stealing. So as you can see, I've seen two posts. Maybe it's from yesterday. Let me try to see. I'm exploiting now the actual payload, and payload is sent successfully. What you can see in the actual payload here is this Python code hidden inside the Jinja templates. So you can see here that I'm trying to injecting code to open the service account token file and then post it to the webhook site. Let's go back, and you can see that the webhook, the actual service account token was taken from the container through this attack. Okay, that's it. Okay, you've been pawned, as usual. Okay, now let's go over to the protection, which is the protect stage. So what I'm doing is I'm retrieving this observability object, which I told you, which is the application profile that contains the system calls. I'm using kubectl get application profile, saving it as a JSON file, then running a small script to convert the list of the profile to an actual application profile, CRD, that Kubescape knows to handle. I'm deploying it. Now I need to tell the Kubernetes deployment to use this profile, so I'm going to patch it now. And the actual profile is set up. Let's see that the pod is coming up and not crashing. Okay, so it's up after I've added the new seccomp profile. Now let's try to exploit again the CVE, and now fingers crossed. I'm running the same script, so doing all the technical parts of the exploitation itself. Okay, let's try to see. Okay, so we don't have any incoming data, and let's hope that it's going to work. Again, the payload itself printing out. And now I'm executing the attack. I've sent the payload, and nothing came in here. So actually, the exploit didn't work because it caused during the exploitation, and I've used the system call that I needed to use the system call that wasn't available in the profile, and the profile blocked it, so the exploitation was stopped during the middle. So, and then just to show you like good side effects that if I'm coming and I would try to open a shell in this container, for some reason I'm allowed to right now, which is surprising, but in general, most of the cases, I would be blocked. That's strange because I chose it yesterday. So eventually there was a fluke in the demo, but in general, that's the idea. So let's go over to the next slide. So just like a few alternatives to seccomp profiles, I'm not saying that seccomp profiles are a good thing in the world, like the best eventual solution that you have, but they are there. They are in the ecosystem of the containers. So trying to introduce any kind of other solutions, and by the way, I love the Landlock LSM. Anyone who wants to read something interesting, it's a really cool project. All the others are really hard to implement in a containerized environment. AppArmor and SC Linux are there, but they are like really hard to move. Like they have the same problem as seccomp, that mostly you can only work with predefined profiles, and it's super hard, and it's either too permissive or killing your application. So it's not an easy world. But in general, seccomp can be a really great way to protect and harden containerized environment. And there are tooling here, and anyone who wants to contribute to the open source project and play around with it, you're welcome to join our the Kubescape Slack. Come to our website, and you can see where you can join the community meetings and the Slack channel. And in general, we are really trying to like gap the usability problem around seccomp profiles and make it usable, because it's really important to harden these environments. that's it. Thank you very much, and if there are any questions, I will be happy to take. I don't know, how is the questioning working through the phone?
Hello, thank you for your presentation. So I have a question. How can I justify to my CISO that I'm going to have to spend several hours with developers securing my containers when there's also a possibility that some of the CVEs, as you mentioned, they are not even covered by SecComp? Is it worth it? How can I justify that? And the level of complexity that it comes with that?
So it's a great question, and thank you for asking that. So the way I can explain to CISOs, and I'm on the vendor side here most of the time when I'm talking to CISOs. So one of the major problems that CISOs have today is that the overwhelming number of CVs they need to somehow manage, and by saying that SecComp is like a way to prolong the time that you need to invest into updating the actual applications. When there is a CV out, then you have 30 days of like patching that CV. But if you have a SecComp profile, and by the way, I think that most compliance frameworks are also supporting this claim that you can prolong this 30 days to even 90 days if you have these additional protections in place. So the way I think to convince a CISO in this case is really to say that, look, one of the biggest things that's hurting you is the overwhelming number of vulnerabilities that you need to patch, and you need to have so this is a way to give you much more time and limit the number of CVs you need to patch eventually in the environment. Again, this is not hard science, okay? Because not it's hard to tell which CVs can be exploited and which can't given a given SecComp profile. But as a rule of thumb, and many of these compliance frameworks that CISOs are dealing with are working with a lot of like these high-level decisions, which are rule of thumb. You can save time for yourself in the patching and the number of patching you need to involve.
When you're profiling all the SecComp profiles dynamically and like in the cluster, how do you prevent accidentally capturing something like a clone operation or somebody like the danger system calls you wouldn't want, but like your container is accidentally making those system calls? How do you make it more secure than the default one?
I'm not really sure that I understand what you mean by accidentally, and I tell you why. Usually when I get this question, I get in this forum, please confirm if I'm right, but usually I'm getting this question in a way that people are asking, what if I'm capturing during the profiling a real attack? There's a real attack and I'm just like capturing, I don't know if you saw that I was able to open the shell on the container, which was like sort of strange because maybe when I profiled this container, I opened the shell and it was just captured and therefore it went into the profile automatically. So yeah, it's something that either you are generating these profiles in the CI/CD processes, like in staging environment and capturing and then rolling out to the production with the profile. And in theory, you will have if you're doing it through GitOps, then you will have a clear paper trail of what was added and what was changed during the time. But I will be happy to discuss it further if we'll have time afterwards. That's it. Yeah. Thank you very much, guys.
Hi, welcome. Thank you so much for coming to B-Sides Las Vegas. This talk, Turla on the Side, is being given by Adam Adamitis. And I have a few announcements to make before we begin. We'd like to thank our sponsors, especially diamond sponsors Adobe and Aikido, and our gold sponsors, Formal and DropZone AI. It's their support, along with our other sponsors, donors, and volunteers, that make this event possible. These talks are being streamed live, and as a courtesy to our speakers and audience, we ask that you check to make sure your cell phones are set to silent. If you have a question, please use the audience microphone, which is over there, so YouTube can hear you. And as a reminder, B-Sides Las Vegas photo policy prohibits taking pictures without the explicit permission of everyone in the frame. These talks are all being recorded and will be available on YouTube in the future. Thank you so much, and with that, thank you, Dan.
Of course. Good morning, everyone. Can everyone hear me? Good in the back? Awesome, awesome. No? Kind of? Better? Do you want me to just yell? I can yell for the next hour. Bueller? Bueller? Okay, there we go. Now we're good. All right. Thank you guys for all coming today. You could be literally anywhere else in the world, but we have all chosen to be here at Vegas to talk about one of my favorite threat actors in the entire world, a group called Turla. This is a group who's known for backdooring the back door. So, fun little fact about me, my name is Danny Adamitis. I am a distinguished engineer at Lumen Technologies. It's a great company that pays me every 2 weeks. Why, I still don't know. I've been in the CTI space for about 10 years. I was part of 2 court authorized disruptions. I drink way too much coffee, so I'm going to be speaking very, very quickly for the next 45 minutes. But on the bright side, I do have one redeeming quality. I have this wonderful dog named Cookie. She unfortunately couldn't be here, but she's going to be with us throughout this entire presentation because sometimes you just need a little bit of levity to cut the undertones of how horrible the internet is. Moving on. So we're going to talk about how we first discovered a group called SideCopy, how we then started moving into the Secret Blizzard or Turla space, and we're going to talk about the larger context, some questions, and what this all means to us. So first section, discovering a group called SideCopy. Or as I like to put it, the part of the internet that isn't PRC operations, ransomware, or artificial intelligence. It does exist, people. It's just very, very small. All right. SideCopy. For those of you who are unaware of them, this was a Middle Eastern Pakistani-based group. They've been active since about 2019 based off some public reporting, and their TTPs are just a little bit different than the Transparent Tribe, if you're familiar with that group. They're known for predominantly using things like phishing and a combination of open source and custom frameworks. We're going to kind of get into this one a little bit more. They're kind of just trying to evade EDR. They're not really going to be the most advanced, sophisticated group we've ever talked about before in the world. Because they are more of a regional actor, they have a regional focus in Southeast Asian organizations. So again, think of places like India, there's a little bit in Nepal, Jordan, Iran, kind of that area of the world. They are known for targeting things like government entities, law enforcement, critical infrastructure, military entities. And thus far, we have seen a lot of focus on offensive operations for the purposes of espionage, but there was a couple things in there that just made me kind of pause for a little bit that we'll kind of get into in a minute. So one of my favorite questions is whenever I start talking about these wonderful campaigns or one of these actors, I always inevitably get a question from someone afterwards that goes, hey, how did this all start? And like, what just tipped you off at first? So I figured let's just start incorporating that into the slides. Way back in December of, I believe it was 2021, I was just kind of searching through VirusTotal, as all good people do at 10 o'clock at night when you can't sleep, working on my YAR rules. What else would you do at night? And we came across a wonderful link file that had the words Microsoft 10 AirEye. AirEye was with the I, that's their misspelling, not mine. I know that, that's why I have to call it out. I got yelled at for that one. We started to then analyze this wonderful link file, and we discovered this kind of malware family that we're later calling reverse wrap. The really interesting thing about this that piqued my interest is they had a capability that was specifically targeting removable media and things like USB drives. They were trying to copy all the contents of anything that was on a USB drive and then trying to propagate to it. this was kind of interest. If anyone here has a background in critical infrastructure, a lot of those networks tend to have an air gap. Oh yeah, but we still need to transfer files from one system to the other. So how do we do that? Propagate over to USB drive. Yeah, there we go. So once we started to extract that, we were able to get some command and control IP addresses, and that's kind of where this all started. Now, the slightly more in-depth version of how that all worked looked a lot more like this. Since we do have a full 45 minutes, we'll kind of go over all this. They were sending these zip files as a phishing lure. Once you unpack that zip file, you would get this Microsoft shortcut file or a link file, LNK. This would deploy some sort of decoy PDF document that would be about some UN sanctions, the state of the military, the latest news sample, just something that we think would kind of pique the interest and make people not realize that there was 14 other things happening in the background. We were then seeing them actually use things like compromised domains, which was kind of interesting because, again, they were just kind of living, somewhat of a way, living off of a domain that we think people would actually legitimately visit, and it would kind of, lower that risk score. From there, they would then use a whole bunch of executable HTML code, which all resides in memory because, again, writing to disk is very, very bad. If you are a red teamer and a new person, do not write to disk. They would then start running multiple modules. The first one would check for things like EDR. They would then have another in-memory loader. And for some strange reason, they then deployed 2 agents on every single device because, redundancy is important. Don't do that either. But it's what actually happened. So some of the more common malware frameworks that we have observed from this group, we saw one called Night Fury. So this was back in 2022. This was kind of interesting because it was a new capability that they were developing. So at the time when we did this, it was all written in C++, and they actually had 20 native functions in 20 different spots that they were going to use. However, about 11 of them were just to go into a big loop. So they're doing it, guys. They're trying, all right? We're just pushing the prod, and they're just like us. Just like us. Prior to that, they were using another tool called Alicore. This was a Delphi-based tool. Again, this is on GitHub. It's been around forever. I think it was just way too noisy. Everything was transmitted in the clear. It's just really bad OPSEC. No one likes Delphi. It's a pain. So they started developing this wonderful Night Fury tool. The second one, and kind of their main kind of flagship module at the time, was a tool called ReverseRat. ReverseRat was a custom tool written in .NET. It had all of the fun, wonderful features we all know and love. You can upload files, you can download files, you can copy to clipboard, you can do things like play with removable media, you can write to the registry, you can delete the registry key because you realize that's actually the local one and not the HTML one. It's great. So that was kind of their main tool. We saw this one. This is where I spent a lot of time just because it had some of those kind of really unique capabilities that kind of, in my mind, prefaced that there was this interest in doing more and kind of going after some of these other targets. And then, of course, we found their third tool called Ares. For those of you who know, this is a publicly open source project. It's on GitHub. It's a Python-based tool. But the fun thing about this one is it runs on Linux because apparently you can also hack Linux devices. No one ever checks those. And again, once we started doing this, we started to kind of write pictures. I work with Ryan. Ryan loves pictures, so therefore he asked me to always write pictures. And this is what we get now. So I have to explain to him how this all sort of works. We were able to find some of these C2s, and then we were able to start enriching this with our NetFlow. For those of you who don't know, I work for a wonderful company called Lumen. Lumen used to own Level 3. Once you own Level 3, you get to see NetFlow on things to traverse through the Level 3 network. You get fun insights into the entire world. This is the result of that. So we were able to start identifying some of those lovely C2s that you'll see right there in the center. Once we identified those C2s, we can start to see who was connecting to those C2s over the known C2 ports. This allowed us to identify some things like the Afghanistani government, a couple telcos in Afghanistan. We also saw a couple other connections from things like the Indian government. We saw, I believe it was 2 different Indian powers. One of them was a power generation, one was power distribution, and things like the Jordanian government. So if you had a strong interest in the Middle East, seems like a pretty good one-stop shop, right? It's awesome. The other fun thing we were able to do with some of our lovely NetFlow is not only could we identify who the victims were, we started to kind of do what I call working upstream. So we could see who was trying to remotely administrate all of these known C2s that we were able to find in things like VirusSolo from those lovely YARLs we talked about before that I wrote at 11:30 at night that still somehow kind of work. Not great, but kind of. So once we were able to look at all of that stuff, we could see them RDPing into this, and that allowed us to find that kind of second or bottom set of C2s. We were then able to kind of do this and start to build out that more holistic picture. And once we started to do this, we started to see where else they were coming from in Pakistan, if there was any other connections, or if, I don't know, there was any other C2s that were talking to them. That would be so weird. Anyway, let's talk about Hack5 for a minute. There's no reason at all we're bringing this up. For those of you who don't know, Hack5 is a commercially available tool. They usually actually have a table out here somewhere. I don't know if they're here or not this year. But the unique thing about them is they provide hardware-based pen testing tools. So when I say hardware-based token, I mean they actually just think like a physical device that you're going to plug into a USB drive. Or their very common one, if you guys have been around, has been the Wi-Fi Pineapple, where you can use that to kind of break into somebody's Wi-Fi. You have, you know, the land turtle, packet squirrel, all of their lovely things. But the really interesting thing that I was trying to emphasize is the fact that you actually have to be close enough to a network that you can touch a piece of equipment, which is weird because usually we talk about things like remote operations. The fun thing about this is, again, shout out to our one-way Hack5 guys, they have this lovely banner that they display on port, 8080 where it says, I'm a Hack5 C2. It makes identification of malicious activity just oh so much fun and easy. And again, once we're able to start searching for that banner, we can start to get a couple of IP addresses. We're calling those our lovely command and control servers. Once we have those lovely command and control servers, do you remember that NetFlow we talked about on the class side? We're just going to throw all those IP addresses in and see who's talking to these things, and maybe that can give us some fun insight. And sure enough, once we started doing this, we found that there was one particular server that was getting a whole bunch of connections from things like Indian governments, like Indian national government organizations, and a whole bunch of connections from other Indian government organizations that weren't located inside of the area of India, probably their Ministry of Foreign Affairs. I don't know. So this was the actual IP address itself. It was the 185.217. And the fun thing about this is we saw remote administration from these other two IP addresses. For those of you who love reading CTI reports and just love to memorize IP addresses like myself, one of those was actually reported on by Team Cymru. Shout out to Team Cymru if you're here. As being a known side copy C2, so we then have a known confirmed C2 with the confirmed malware sample being used to administrate a known Hack5 server, and then that Hack5 server going after basically the exact same governments. But the fun thing is, with this particular bottom row, it was a hardware-based solution. How do you get a hardware-based solution into a government network? Would you like to chime in, sir?
Somebody has to sneak in and put it there.
I mean, I don't know. That's just speculation. I'm not here to speculate. I'm just here to report facts. All right. Thank you. We'll get you crayons later for lunch. All right. So this is really interesting to me because I feel like we always talk about proximity-based attacks in the abstract as something that doesn't really occur. And in my mind, this is probably only the third documented instance of this occurring. The first and the foremost one that everyone usually thinks about was that lovely attack that happened with the GRU in the Netherlands, where they were able to see someone using a Hack5 or a Pineapple to try to break into someone's Wi-Fi because they just wanted to do it that way. There was a second report that came out from Biloxi in which there was another Russian GRU group that was basically hacking into the Wi-Fi right next to their target and using that to kind of bridge over the gap. So again, these things do happen, but reporting and documentation of them is incredibly rare. So this is just kind of my other call was just start looking for this stuff because it's probably out there and it's probably happening a lot more than any one of us is actually noticing or talking about. So let's be the change we wish to see in this world. So after we started doing this, we started looking for other C2s thinking, hey, if they made that mistake once, bet you $1 they're going to make it again. Maybe we can find some other really interesting command and control nodes that were actually talking to them. And that's when we found this first node. This one did not have any banners at all. In fact, there was no IP history about it at all. There was no domains, there was no scan entries, there was no census. There was pretty much nothing in any of the open source, which made me go, who are you and why are you here? Enter phase 2. Let's go hunting for bears. So, as we mentioned, the lovely dog. This is Cookie. I'm Booker. All right, moving on. Secret Blizzard, aka Turla. So this is the kind of main premise for the talk, is this wonderful group called the FSB Center 16. They have a global remit, and they are, I would argue, one of the most sophisticated and most advanced threat actors in the world, bar none. Yes, I'm talking to you, but I'm even including China in that talk. They are really cool because they like to do things like this attacker in the middle framework, where they will actually hijack connections for legitimate things. There was a great report put by Microsoft, I think about a week or two ago. They also, and this is my favorite, started hacking other hackers. And again, who doesn't want to hear a talk about hackers hacking hackers in Vegas, right? They also have that wonderful peer-to-peer framework that used to be what they were calling Snake, and they actually use things like Satellite for command and control. And again, they're just, it's just, I feel like they take pride in their work, and every now and then, you gotta acknowledge the fact that, man, these guys are really prideful, and they just try it that much harder. Unlike, the side copy guys, they don't really try. They just want to kind of get their job done, and it's cool, I guess it works, but, it's not fun for us. We're here to have fun. They are predominantly interested in foreign government entities, so think of governments, think of Ministry of Foreign Affairs, critical infrastructure, and of course, other hackers that could give them access to everything because that just makes their life easier. And again, they're focused predominantly on long-term cyber espionage. Now, this was one of, I want to say, in my mind, one of the watershed reports. This was done by our lovely counterparts at the UK NCSC. I believe this was about 2019 at this point, but this was the first documented instance of Turla actually hacking into an Iranian group. I believe it was called Hazel Sandstorm, and they were using that to deploy their own tools. And again, this was just kind of that weird moment where everyone always talks about, well, why don't we just hack the hackers and just use that to get all the exfil and do everything we want to do? This was the first time anyone actually documented this in a public space that we can all now talk to and reference. The way they do this is we've observed 3 predominant tool sets. And this is the part where I will say we did work with Microsoft. We love those guys. If you're watching, you're amazing. They have 3 predominant tool sets. The first one is called 2-. 2- was a super lightweight survey tool. So it's basically saying, am I in a VM? Are you actually running? Is this a real system? Can I actually, enumerate things like MAC addresses? And if they said, yep, this does look like a real system, we're going to use this to then download an additional module. We're going to decrypt that, and we're going to run it all in memory, because memory is where you want to live. We then observed a second tool, and this is kind of their big one. It's called Tiny Turla. Not to be confused with Turla, who's the actual group. They also have their own little malware family called Tiny. They were basically used to, again, it persists as a service. So again, you do have your persistings. You've seen them use this for years and years on end. The ability to upload, download code, do remote execution, and play with things like the registry. This one is a little bit more fun because the binary actually resides exclusively in the registry itself. And if you've ever tried to search the registry of an entire enterprise, is a really, really long day for you. So it does work, and in there they also then actually have the IP addresses in a different registry key, so that way even if you just recover the binary itself in something like memory, you would then need that second component to actually know where they're talking to. And the last module we saw was Shatuzi. This was used to basically copy the contents of clipboards. And again, some people say, well, why would you want to copy the contents of a clipboard? And I look at someone like Wendy and go, hi, Wendy, talk to me about 1Pass and how everyone just uses a password manager any day, and then how you just copy that over and paste it. So if you were to copy the clipboard, you basically just have everyone's usernames and passwords for pretty much everything. So this is kind of what we saw. This was the initial C2 we were talking about before, out up there in the top right-hand corner, where we saw that starting to communicate with a couple of these known side copy C2s. So again, at this point, we're still trying to enumerate out these side copy C2s through a combination of things like NetFlow, our lovely Yara rules. We're even doing some fun pivoting based off of things like RDP circs and usernames that are being used across multiple things. It's super fun. And we noticed that at a certain point, I think this was around May of 2023, we saw that there was actually getting beaconings to that Turla C2 from a Afghan government IP address. So this was kind of a very unique and interesting thing where, before they were hacking the hackers, now they're hacking the hackers to use their C2 to deploy their own malware to a particular network. Why they're deploying their own network? Maybe they just didn't like the way they were doing things. Maybe they had an interest in a different part of the network. Maybe they wanted different files than, the Pakistanis were grabbing. There is a number of reasons. But again, we believe that the initial access vector was actually someone else's command and control. We then actually saw them starting to poke at some of the other C2s, and we even saw them starting to poke at the Pakistani ISI operators themselves. Now again, I know that there's probably going to be one person here who's going to scream, PCAP or it didn't happen. So this is my PCAP or it didn't happen slide. So this was the known side copy known side copy IP address. This was actually based in Pakistan. It does resolve to a real IP address. And then we actually saw this being used to RDP into a known side copy C2. This was the 130, 185. And the fun thing about this is you can actually see the first scene and last scene from our lovely telemetry. At the exact same time, you'll notice the exact same IP address was also talking to a Turtle C2 over its known 9443 port. And the fun thing is, if you look at the first scene and last scene times, it's the exact same time. So again, this is the part where I know someone's going to inevitably say, but it's a dynamic IP address. There could be multiple things happening. How do you know it's really the operators who are RDPing while Turtle is hacking into them at the exact same minute? This is a part where I'm going to go, this is about as good as it's probably going to get for us. So yeah, I feel pretty good about that assessment that, they actually did manage to move from the command and control servers of the site copy actors back down to the actual operator's workstation. This was, again, a huge thing in my mind. We have never actually had a documented instance of a known nation-state threat actor compromising another known nation-state threat actor's operating workstation. So, of course, I then called my spirit animal Cookie and said, hey, what do you think of all this? And she said, what the duck? So this is kind of what it looked like. Again, we were able to then kind of see them continuously interacting with a whole bunch of these Catawba IP addresses and Nexiums. We were able to see them continuously interact with the Afghan government for about months on end. I think we still saw stuff as recently as, late 2024, early 2025. And then sporadically, we would actually see some of these Pakistani IP addresses popping up in our telemetry where they were actually interacting with the exact same Turtle IP address that was being used to interact with all the other C2s. Yeah, it's fun. So, section 3, the absence of data, or when not having any data becomes your main data point. So, as we kind of talked about before, we were talking about some of the main malware families that we were predominantly being seen from the side copy threat actors. So again, we have a level report. You guys can read it. The main ones were there was a tool called Weisscotton. This was a Go-based tool. We think that they were using this predominantly to go after some of the more Linux, Unix-y systems because you get that lovely portability that everyone loves. Action Rat, this was kind of like a variant of Reverse Rat. This was kind of a little bit different, but again, .NET, it's targeting things like Windows systems. We saw Crimson Rat, so this was actually being used to target things like Android devices. Again, another super well-known documented family. We observed things like Alicore, again, super well-known documented family. It was written in Delphi. It's being used by everyone. And we actually saw the Turtle actors interacting with almost all of them, except for the Ares Rat. And this was the part where I just couldn't quite put my finger on. Why would you hack into seemingly everything? You were on the operator's workstation. Clearly, you have the credentials at that point in time. Why are you not targeting this one particular group? So if anyone here was at PivotCon last year, we had our older counterpart, Seth, gave a wonderful presentation about Ares Rat and how he was tracking that. Shout out to Seth. And we were able to start kind of going into this, and this is where we started. I kind of jumped down this rabbit hole of what is so different about this one particular malware family than all the other ones, and why are they not targeting them? And this was, and again, we started kind of enumerating out all of their infrastructure. We did that same methodology we talked about in the earlier slides, where we were able to kind of see where they were coming from in Pakistan. We were looking for remote connections. We were then able to actually start seeing some of these IP addresses, and we saw what looked like, sustained connections to their admin page. Fun thing about their admin page, they decided to try to hide themselves as a pfSyncs firewall and a VPS, because that totally happens in the normal world all the time. And while that might help them evade scanners, if you have something like NetFlow, it just stinks like a sore thumb. That all of a sudden you're going to see 10,000 connections to some random ephemeral port and this one random thing. And then if you actually do something like URL scan and you see pfSyncs, it becomes pretty easy. And I just don't quite understand why they never targeted this. And then that kind of led me to my next kind of correlation. So we saw our wonderful secret Blizzard actor, or Turla, in the top right-hand corner. We saw them hacking into all the C2s. We saw them actually deploying their stuff to places like the Afghan government. We actually saw them in the Pakistani network. But for some reason, we never actually saw them using that same C2 to deploy any of their malware into places like the Indian-based networks. And this was just kind of a really, in my mind, interesting data point of why would they go through all this trouble where clearly they had the capability, they have the access, they've done this before. What makes some of these other Indian government targets so different that they don't want to actually deploy any of their own malware? So This is, so again, kind of going over some of this, we saw them, in my mind, they clearly had the capability, they had the capacity to do this stuff, but for some reason they didn't. So this is kind of when I put on my lovely international relations hat, and we started to look at this from a fun geopolitical lens and wondering about the IR and the connections of all of them. The only thing I could think of is there was a geopolitical preference to not be discovered in any of these networks. The fun, unfortunate thing about performing these sorts of operations is anyone who does them know at some point in time you're going to get caught. It might not happen today, it might not happen tomorrow, it could be a decade from now, but every single person who has done any sort of hacking event at some point in time runs the risk of getting caught, and if you get caught, it's going to cause a bit of a stir. So there is a fun connection between the Indian government and the Russian government. As we kind of, well, I think I mentioned this before, Modi was recently reelected in 2024, and his first international visit was to Moscow. So again, that's usually where you signal who your strongest preference is or where you're trying to build relations. So again, I think that there is a whole kind of budding relationship there. There's also some connections where the Russian government is selling a bunch of their oil over to the Indian government, and again, they need to continue to sell that oil to have funds to then prepare for the war that's still going on in Ukraine. There is also this fun thing where a whole bunch of Indians have been being duped into, being conscripted into the Russian army. So again, there might be something where, they're clearly benefiting from this and, they really like the status quo. They might still have kind of what we call this information need or this desire to learn about what's happening in India because it is a large regional player, but they might have the political will to actually get caught doing this. So what do you do when you need to have information about them, but you can't actually be in the network yourself? This is that fun little middle ground where you're like, I'm not touching you, I'm not touching you, I'm not touching you. But you're still basically doing exactly that. You're just kind of poking the bear, you're collecting all of that wonderful information you need, and you can use that to still kind of answer all the questions that you need to do. And again, this is not my opinions, this is European Council for Foreign Relations and the BBC, so good enough for me. Section 4, conclusions. So this was kind of my favorite topic was what happens when you start backdooring other people's backdoors. In my mind, there has been 5 documented cases of Turtle doing this, and to my knowledge, I think they are probably one of the only group that's been publicly attributed to performing this actual tradecraft. This is kind of, sometimes called a stunt hack or, something where everyone talks about how great it would be if they could do this. This is one of the few groups that's actually putting that into practice. The first one was, of course, the NCSC thing. There was a second instance, and this was documented by Mandiant and now Google, where they purchased an expired domain and they used that to drop their own tools. We've also seen this from SecureList, where there was a sys actor who was using Thomas, and then they were then dropping their own tools. This is, of course, the 4th instance. And of course, we saw the 5th one, which was Amadei. If you guys are here and from the CyberCrowd crew, you know that this is a well-known malware. It's a platform service. It's being used by cyber criminals. It's seemingly everywhere. And they were using this to get more information about people, particularly in Ukraine. So, and kind of the last couple things. Why should I care about any of this? Well, I feel like there's been, as we kind of talked about, a number of cases where we've kind of seen what I call snapshots in time. No one has ever actually done a 2-year comprehensive study of what exactly is happening and how they move from one C2 to another, back down to the workstation, using that to then deploy their own tools, choosing to go into some networks while not choosing to go in the other networks. I feel like this kind of really helps reveal a lot about how they think through these problems and how they work through them in a way that you're just never going to get if you just did a lovely IR and you go, oh cool, we found 2 malware families on the exact same system at the exact same time. That's so weird. It doesn't really talk about how they view these problems and how they start to think through them and where they decide to go. The other fun thing that this is one of my favorite data points, not only did we see them observe or hack one C2, we observed what looked like signs of compromise or beaconing from 33 different C2s over 2 years. So again, everyone kind of goes, oh yeah, well we think this happens and they probably have access to a bunch of things. This is one of the few examples where we actually have what I call hard data points to point to and talk about how exactly this is occurring. And again, in my mind, the greatest thing is this is the first time we've actually seen a nation state move back down onto those operator workstations. And at least in my mind, if we know if it's Tiny Turtle, they had persistence, they had the ability to move laterally. Anyone here works in the red team, how many of you guys have EDR expired on your home workstation where you do all of your operations? And how many of you guys start checking that registry for weird keys? Yeah, Yeah. So if you were hypothetically on that network, they probably could have persisted there for a very long time and gotten just absolutely everything that they wanted. All right, some of the fun unsolved questions. As any good person does, you always talk about the unknowns, or the things that you weren't quite able to figure out, but maybe some of you guys do. So if you do, come find me later. I'll buy you a beer. All right, so my first thing was, how was SiteCopy able to get some of this Hack5 equipment in? This is the part where it would indicate that they either hacked some level of access to these facilities, they kind of did something where they were hacking from the parking lot, or they had someone on the inside. But that's just kind of my big thing was, I think it's not often that we actually get to see these Hack5 devices being used in the wild for real-world attacks. And then the question always becomes, how are they doing this? And do they have some sort of travel team very similar to what we saw from other operators like the GRU? As for the Turla questions, why did they choose SiteCopy? There's, again, seemingly every nation in the world has their own hacking organization. There's how many private sector offenses. There's how many cyber criminal groups. There's how many botnets. They could literally target anything. These guys are actually really, really good at what they do. But what was it about this one particular group that made them stop and go, yes, that's exactly who I want to start targeting, and that's why. The other big question that I don't think we're ever really going to get an answer to was, why were they so comfortable doing things like deploying their own malware families and their own tool sets in places like the Afghanistan government, but they seemingly chose not to do that for places like India or Jordan or Iran or some of these other networks where we actually know that the SiteCopy actor had access, but we didn't see anything from the actual Turla side of things. And again, this was the other fun thing, is if we're going full circle back to the very beginning and the reason this first caught my attention, there was this weird angle where we saw them targeting what looked like power generation and power distribution companies. We know that they had things like USB modules. We know that they had the ability to do things like copy clipboards. We know that they were trying to propagate, and we believe that the Pakistanis were just doing that for their own purpose. Secret Blizzard also has their own capabilities to go after some of these critical infrastructures. What happens if you're trying to then do an IR where you see Turla walking in with stolen credentials being used by a different actor into that network? This is kind of this fun thing where I know this is where everyone always says and clamors that they want immediate attribution from doing some of these instant responses, and they want to know exactly how this happened and what happened. This was something that took me over 2 years to piece apart. So again, if you are one of those directors who's demanding for things, just give your people a little bit more grace and mercy. Sometimes it takes more than 5 minutes to kind of put all of this together. Okay. And at the end, this was actually a joint endeavor, as I mentioned before, with our lovely counterparts at Microsoft. There is a great group of guys out there who is focusing on the Russia group. They also did their own blogs. They kind of focused a little bit more on the malware. That was called Operation Freeloader. And then they did the second one on Amadei. We at Lumen kind of focus a lot more on network telemetry because that's kind of our special sauce. Obviously, they're very good at this. And again, better together, everyone wins, except for the Russians, but we don't care about them. Okay, and questions? Sorry, I'm a little early. Do you want me to? Goes short by a couple minutes. Yeah.
Thank you. Thank you for the great talk. I really enjoyed it. I had the question that you mentioned you saw some evidence of this kind of activity by Turla into possibly 33 different C2s of different malware families. So maybe I missed this, but some of these were the ones used by the Pakistani ISI.
Yep.
Some of these were maybe the cyber criminal botnets, etc.
So it was 33 of the Pakistani ISIs,
Okay.
and then there was also cyber criminals over here too. But I had to kind of time scope it a little bit. Otherwise, I would just keep doing this forever.
So within the 33 that you mentioned, all of those were SiteCopy's infrastructure?
We assessed that all of them were associated with either SiteCopy and or Transparent Tribe. So it's two different Pakistani-based groups.
Okay, thank you. And
Yep.
follow-up question. I didn't really totally understand your last comment about why would the ISI get into power generation, power distribution in India? It seems kind of obvious to me. So what are you saying is, why is Turla getting into there as well? I didn't quite understand that. Thank you.
Yep. So It does make sense that the Pakistanis are very interested in India. There's been a bit of a warm, hot, cold conflict there in the Kashmir region forever. I'm sure you guys are familiar with this one. I think it was more of the point I was trying to emphasize was that while the Pakistanis appear to be kind of pre-positioning themselves, the way you do that is obviously gaining some sort of access, getting things like admin credentials, getting things like network maps. That's exactly everything that Turla would need if they wanted to try to then move into that same network. So again, it's one of those things where what happens when you have, I want to say, side copy performing all of your kind of initial reconnaissance and you're laying out the land, and then you have someone like Turla coming in on top of that to actually then start hacking that. And if you're someone who works for an incident response firm and you're trying to piece all that together, it's going to look very weird and very awkward for you. So again, it's just kind of in my mind trying to bring up the concept that if you see signs of compromise, that means that there could actually be 2 or 3 other actors who are also residing in that same network who have used the same tradecraft. I hope that makes more sense. If not, I'll find you afterwards. Oop.
Excellent. No, great talk. I'm curious, is there any way you're going through differentiating between Turla purchasing access versus Turla compromising groups like SideCopy and even more broadly across the community? I mean, what are some of the indicators around your analysis of how you differentiate between those two? Thank you.
Yep. So for things like this one, it's in my mind a little bit easier. There's been no evidence or documentation that people like SideCopy has ever sold access to anyone. They appear to only be hacking for the purposes of their own geopolitical interests. We've also kind of seen things before with, I think, some of the Amadeus, where typically if you purchase access, you'll only get access to like a set of creds, or you might get some information. I think we just saw what looked like just a large amount of data exfil from some of the backends that, again, we only ever see the actual cyber criminals coming in from. So the fact that they're kind of using that same door, in my mind, indicates that they didn't actually just purchase something. They probably, gained some sort of access. And again, as I mentioned before, these guys are really savvy. They're good at JavaScript. They're good at all this. They probably found some sort of weird, auth bypass that, again, I'm sure you're going to hear all about auth bypasses with things like cold book strike and stuff like that. They probably have someone doing something similar. But great question. Anyone else? I'll also be around for parts of the day too. So if you guys have something that you don't want to put on camera, I'm around. Cool. Awesome. Thank you guys.